હેલો સ્ટુડન્ટ્સ, કેમ છો? મજામાં? આવી ગયા તમે? ચલો આવી ગયા છો તો ચેપ્ટર નંબર 3 સ્ટાર્ટ કરીએ. ચેપ્ટર 3 કરંટ ઇલેક્ટ્રિસિટી. Let's continue with chapter number 3 current electricity. In this chapter we have studied about electric current, current density, Ohm's law, relation between current density and electric field, that is vector form of Ohm's law. J vector is equal to sigma E vector. After that we have studied about drift velocity. Then we have obtained the relation between drift velocity and electric current. Then we have obtained the relation between current density and drift velocity. Then after we have obtained the formula of resistivity and conductivity. Whatever formula of resistivity and conductivity we have obtained using the concept of drift velocity, that we have to use in today's topic, temperature dependence of resistivity. We know that resistivity does not depend on dimensions of conductor, it depends on type of material. Resistivity of material depends on temperature. Resistivity of material depends on material also, it depends on temperature also. As temperature changes, value of resistivity will change. Then how the value of resistivity changes with temperature? For limited range of temperature, when temperature is not too large, at the time relation of resistivity with temperature is this: rho T is equal to rho naught 1 plus alpha T minus T naught. Rho T, that is resistivity at temperature T. At any temperature T, resistivity, that is rho T. Rho naught, that is resistivity at a reference temperature T naught. Any reference temperature we have to select. At that reference temperature, resistivity is rho naught, and with respect to this reference value of resistivity, we have to measure resistivity at temperature T. Alpha, what is alpha? That is temperature coefficient of resistivity. Alpha, that is temperature coefficient of resistivity. From this formula, tell me what should be the unit of alpha? What should be the unit of alpha? Here, from this, rho T upon rho naught, resistivity upon resistivity will get cancelled. So, alpha, that is reciprocal of temperature. So, we can say that unit of temperature, that is degree Celsius inverse or Kelvin inverse. From this relation, we can find the unit of alpha. So, unit of alpha, that is degree Celsius inverse or Kelvin inverse. Alpha is called the temperature coefficient of resistivity. This formula is very important. When value of reference temperature and resistivity at reference temperature is given to us, and if they are asking you to find value of resistivity at any temperature T, then we can find resistivity at any temperature T using this relation. So, my dear students, please remember this formula. Rho T is equal to rho naught 1 plus alpha T minus T naught. For metals, alpha, that is positive. For metals, value of alpha is positive. Value of temperature coefficient will be positive for metals. For good conductors, value of alpha, that is positive. If value of alpha is positive, then what will happen? This 1 plus something will be positive. If value of alpha is positive, then as temperature increases, then what will happen? Resistivity also increases. If value of alpha is positive and if temperature increases, then value of resistivity also increases. So the graph of resistivity versus temperature for metals is like this. At a low value of temperature, that is less than 50 Kelvin, the graph, that is non-linear. But after that, graph of resistivity versus temperature, that is linear. So this is the linear relationship. For limited range of temperature, this formula of resistivity is applicable. As temperature increases, resistivity increases. From this graph it is clear that as temperature increases, resistivity increases. We have studied the formula of resistivity. When we have studied about drift velocity, at the time we have obtained this formula. Resistivity rho is equal to m upon n e square tau. What is m? That is mass of an electron. What is n? That is number density. That is nothing but number of electrons per unit volume. What is e? Charge of electron. And what is tau? That is relaxation time. Small n, that is independent of temperature. N, that is independent of temperature. It means as value of temperature changes, value of n will remain constant. For conductors, as temperature changes, n remain constant. So we can say that n is independent of temperature. So m, that is constant, n, that is constant, charge of electron, that is constant. So resistivity will change with this time. As temperature increases, average speed of electrons increases. जैसे ही टेम्परेचर बढ़ाएंगे तो कंडक्टर के अंदर जो इलेक्ट्रॉन हैं उनकी एवरेज स्पीड बढ़ जाएगी. एवरेज स्पीड बढ़ जाएगी मतलब उनकी जो स्पीड है, ड्रिफ्ट स्पीड, वो बढ़ेगी. इंक्रीजेस रिजल्टिंग इन मोर फ्रीक्वेंट कोलिजन्स. एवरेज स्पीड बढ़ जाएगी तो नंबर ऑफ कोलिजन्स बढ़ जाएंगे. टाउ, दैट इज टाइम इंटरवल बिटवीन टू सक्सेसिव कोलिजन्स. So if number of collision increases, then time interval between two successive collision decreases. Value of relaxation time tau decreases. Therefore tau decreases with temperature. As the temperature increases, relaxation time decreases. M, that is constant, n, that is constant, E, that is constant. Therefore we can say that resistivity is inversely proportional to relaxation time for conductors. As value of tau decreases, resistivity increases. Therefore we can say that as temperature increases, relaxation time tau decreases, resistivity increases. So for conductors, temperature increases, resistivity decreases. ये हमारा बन गया MCQ. याद रखेंगे कंडक्टर्स के लिए जैसे ही टेम्परेचर बढ़ेगा क्या होगा, रेजिस्टिविटी भी बढ़ेगी. As temperature increases, resistivity also increases. And we know that resistance is directly proportional to resistivity because R is equal to rho L by A. So as resistivity increases, resistance also increases. Some materials like nichrome, which is an alloy of nickel, iron and chromium, exhibit a very weak dependence of resistivity with temperature. So here I have drawn graph of resistivity versus temperature for an alloy. If we take constantan or manganese or nichrome for an alloy, the graph of resistivity versus temperature is like this. Graph of resistivity versus temperature is like this. This value of resistivity is nearly same at these 2 points. There is minor difference at this point and at this point. It means as value of temperature increases, there is a minor change in resistivity. So we can say that some materials like nichrome exhibit a very weak dependence of resistivity with temperature. So when we take material like alloy, that is the mixture of this type of materials, for that resistivity does not change with temperature, it remains constant. And this type of materials are used in wire bound standard resistors. मतलब समझ लो कि हमने कोई डिवाइस बनाई और उस डिवाइस में हमने जो रेजिस्टर यूज़ किया हुआ है उसमें अगर हमने अलॉय के अलावा अगर कोई और मटेरियल यूज़ किया, समझ लो कि कंडक्टर यूज़ किया, तो क्या होगा कि यहाँ से वो डिवाइस अगर किसी और जगह पे एक्सपोर्ट की जाए जहाँ पे टेम्परेचर बहुत ही कम है, तो क्या होगा, एज वैल्यू ऑफ टेम्परेचर चेंजेस वैल्यू ऑफ रेजिस्टिविटी और रेजिस्टेंस विल चेंज। तो अगर वो डिवाइस हमने जहाँ पे भी एक्सपोर्ट की है वहाँ के लोग क्या बोलेंगे, आपने तो घटिया माल भिजवाया है, आपने जो बोला था वैसे तो डिवाइस काम कर रहा है नहीं, क्योंकि क्या होगा, रेजिस्टिविटी की वैल्यू बदल जाएगी। सो फॉर स्टैंडर्ड रेजिस्टर्स वी यूज़ दिस टाइप ऑफ मटेरियल alloy, and when we use alloy like material then resistivity does not change with temperature. This type of materials are used in wire bound standard resistors. Now resistivity of semiconductor decreases with increasing temperature. Here I have drawn the graph of resistivity versus temperature for semiconductors. From this graph it is clear that as temperature increases value of resistivity decreases. तो यहाँ पे उल्टा होता है, कंडक्टर्स में क्या हो रहा था, as temperature increases value of resistivity increases, but for semiconductors as temperature increases value of resistivity decreases. How? Formula of resistivity, that is m upon n square tau. For insulators and semiconductors, what happens? As temperature increases, number density increases, and this value of n is very large in comparison to decrease in relaxation time. Yes, I know that as temperature increases, this relaxation time tau decreases, but in comparison to this, there is a very large increase in number density. So here the effect of number density is more in comparison to relaxation time tau. So as the value of n increases, then what will happen? Resistivity decreases. So as temperature increases, number density increases, resistivity decreases. So for semiconductors, as value of temperature increases, resistivity decreases. As I told you, R is directly proportional to rho, because we know the relation R is equal to rho L by A. From this, resistivity is directly proportional to resistance, or we can say that resistance is directly proportional to resistivity. So equation of resistance in terms of temperature is R is equal to R naught 1 plus alpha T minus T naught, because R is directly proportional to rho. Therefore value of resistance is at any temperature T is R. What is R naught? That is value of resistance at any reference temperature T naught. What is alpha? That is temperature coefficient. So this is the relation. So this is the relation between resistance and temperature. So resistance varies with temperature with this relation. So R is equal to R naught 1 plus alpha T minus T naught. When they are asking you to find resistance, then you have to use this relation. When they are asking you to find resistivity, at that time you have to use this relation. If temperature, value of temperature is given to us, then we can easily find resistivity using this relation. I hope the concept of temperature dependence of resistivity is now clear to you. इसकी थियरी तो हो गई, अब इसके कुछ एग्जाम्पल और न्यूमेरिकल सॉल्व करते हैं, जिससे आपको इसका कंसेप्ट और भी क्लियर हो जाएगा. Let us solve example 3.3. An electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, which material they have used? Nichrome. That is nothing but alloy as heating element. When a negligibly small current passes through it, its resistance at room temperature 27 degrees Celsius. So what is this? This is a reference temperature. reference temperature they have given 27 degree Celsius. So this is nothing but T naught is found to be 75.3 ohm. What is this? This is reference value of resistance, or you can say resistance at reference temperature. At this temperature, value of resistance, that is 75.3 ohm. So we can write R naught is equal to 75.3 ohm and T naught is equal to 27 degree Celsius. When a toaster is connected to a 230 volt supply, किससे कनेक्ट किया जाए? 230 volt supply. It means potential difference V, that is 230 volt. The current settles after a few seconds. जैसे ही बैटरी कनेक्ट करेंगे तो इलेक्ट्रॉन्स का मोशन स्टार्ट हो जाएगा. आफ्टर अ फ्यू सेकेंड्स वैल्यू ऑफ करंट विल बी स्टेडी एंड दैट स्टेडी वैल्यू ऑफ करंट इज 2.68 एम्पियर. So steady value of current I, that is 2.68 ampere. What is the steady temperature of the nichrome element? जब करंट की वैल्यू स्टेडी हो जाएगी तो उस समय पे टेम्परेचर क्या होगा नाइक्रोम मटेरियल का, that we have to find, that is temperature T. The temperature coefficient of resistance of nichrome average over the temperature range involved is 1.70 into 10 raised to minus 4 degree Celsius inverse. So what is this? This is temperature coefficient alpha. So value of alpha, that is 1.70 into 10 raised to minus 4 degree Celsius inverse. So this values are available to us and we have to find temperature T. We know the formula of resistance R, that is R is equal to R naught 1 plus alpha T minus T naught. R naught, that is available to us, value of alpha, that is given, final temperature that we have to find, and reference temperature that is given to us. But first of all we have to find R. What is the value of resistance at steady value of electric current? So when toaster is connected to a 230 volt supply, when current settles down at a steady value of current, value of resistance R is equal to V by I according to Ohm's law. V is equal to IR, therefore R is equal to V by I. What is V? 230. What is I? 2.68. So 230 upon 2.68, that is nothing but 85.8 ohm. So this is the value of resistance when we get steady value of electric current. So value of R, that is available to us, R naught, that is given. What we have to find? Temperature T. So from this, R by R naught is equal to 1 plus alpha T minus T naught. Therefore R by R naught minus 1 is equal to alpha into T minus T naught. If we take LCM, then it can be written as R minus R naught upon R naught is equal to alpha T minus T naught. From this, if we make T minus T naught subject, then T minus T naught as it is, R minus R naught upon R naught alpha. T minus T naught as it is. What is the value of R? That is 85.8 ohm. What is the value of R naught? That is 75.3 ohm. R naught, that is 75.3, and value of alpha, that is 1.70 into 10 raised to minus 4. So by substituting all these values, we will get T minus T naught is equal to 820 degree Celsius. Therefore T is equal to T naught plus 820. What is the value of T naught? That is 27 degree Celsius, that is the reference temperature. 27 plus 820, that is 847 degree Celsius. So steady value of temperature is 847 degree Celsius. Using this formula, R is equal to R naught 1 plus alpha T minus T naught, easily we can find steady value of temperature. एक और एग्जाम्पल सॉल्व करते हैं. एग्जाम्पल 3.4. The resistance of the platinum wire of a platinum resistance thermometer at the ice point. Ice point. What is the temperature of ice point? 0 degree Celsius. So reference temperature, that is 0 degree Celsius. And at this reference temperature, value of platinum resistance is 5 ohm. So this is value of resistance at a reference temperature that is R0, 5 ohm, and at steam point is 5.23 ohm. Steam point क्या होता है? 100 डिग्री सेल्सियस. So this temperature is 100 degree Celsius and at this temperature value of resistance is 5.23 ohm. स्टूडेंट्स एक करेक्शन करना होगा आपको आपकी टेक्स्ट बुक में. यहाँ पे आपकी टेक्स्ट बुक में 5.23 ओहम नहीं दिया है. एट स्टीम पॉइंट द वैल्यू ऑफ रेजिस्टेंस वी हैव टू टेक 5.23 ओहम. तो यहाँ पे एक करेक्शन करें, 5.23 ओहम. When the thermometer is inserted in bath, when the thermometer is inserted in a hot bath, at that time the resistance of platinum wire is 5.795 ohm. एक और टेम्परेचर दे दिया. अब तक दो टेम्परेचर की बात होती थी. एक रेफरेंस टेम्परेचर हो गया, वन मोर टेम्परेचर दैट इज 100 डिग्री सेल्सियस, एंड नाउ द थर्मोमीटर इज इंसर्टेड इन अ हॉट बाथ. एट दैट टाइम द रेजिस्टेंस ऑफ प्लेटिनम वायर इज 5.795 ओहम. तो उसका रेजिस्टेंस हम ले लेते हैं आर डैश 5.795 ओहम. एंड दे आर आस्किंग अस टू फाइंड कैलकुलेट द टेम्परेचर ऑफ बाथ. सो दैट टेम्परेचर आई एम टेकिंग टी डैश. So simply we have to apply the relation R is equal to R naught 1 plus alpha T minus T naught. ये रिलेशन यूज़ करेंगे. चलो पहले T और T naught के लिए अप्लाई करते हैं. तो R100 इज इक्वल टू R naught इंटू 1 प्लस अल्फा T माइनस T naught. सो फाइनल टेम्परेचर दैट इज 100 डिग्री सेल्सियस, रेफरेंस टेम्परेचर दैट इज 0 डिग्री सेल्सियस. सो R100 इज इक्वल टू R naught 1 plus alpha 100 minus 0. So this can be written as R100 upon R naught is equal to 1 plus alpha into 100. If we take this one on left hand side, then it can be written as R100 minus R naught upon R naught is equal to 100 alpha. Equation number 1. When thermometer is inserted in hot bath. चलो एक इक्वेशन बन गया हमारे पास यहाँ पे अल्फा की वैल्यू नहीं है, तो हमें इक्वेशन ऐसे बनाने हैं कि ये अल्फ़ा कैंसिल हो जाए. अगर अल्फ़ा कैंसिल हो गया तो इजीली हम इक्वेशन से फाइनल टेम्परेचर फाइंड कर सकते हैं, दैट इज़ द टेम्परेचर ऑफ हॉट बाथ. तो मुझे यहाँ पे अल्फ़ा कैंसिल करवाना है, इसीलिए मैंने अल्फ़ा को कहाँ पे रखा है, राइट हैंड साइड. इक्वेशन नंबर 1. व्हेन थर्मोमीटर इज इंसर्टेड इन हॉट बाथ, एट दैट टाइम व्हाट विल हैपन, एट दैट टाइम रेजिस्टेंस इज आर डैश एंड रेफरेंस at reference value of temperature resistance that is R naught. So R dash is equal to R naught into 1 plus alpha T dash minus T naught. वही रिलेशन लगाना है. अब टेम्परेचर बदल गया, यहाँ पे टेम्परेचर T dash लिया तो रेजिस्टेंस क्या आएगा, R dash. Therefore R dash upon R naught is equal to 1 plus alpha T dash because T naught that is 0. So alpha T dash. Therefore this can be written as R dash minus R naught upon R naught is equal to alpha T dash. ये 1 को लेफ्ट हैंड साइड लेके जाएंगे और एलसीएम लेंगे तो क्या बनेगा, R dash माइनस R naught अपॉन R naught इज इक्वल टू अल्फा T dash. इक्वेशन नंबर 2. अब यहाँ पे देख लीजिए राइट हैंड साइड पे अल्फा है और मुझे अल्फा कैंसिल करना है तो क्या करना चाहिए, डिवाइड. तो डिवाइड इक्वेशन 1 बाय इक्वेशन 2. इक्वेशन 1 को इक्वेशन 2 से डिवाइड करें तो क्या कैंसिल हो जाएगा, this R naught will get cancelled, this upon this, so R naught will get cancelled, alpha will get cancelled, then what will remain, R100 minus R naught upon R dash minus R naught, because R naught will get cancelled, alpha will get cancelled, what will remain, 100 upon T dash. Now if we make T dash subject, then T dash is equal to, if we make T dash subject, then R dash minus R naught upon R100 minus R naught and 200. T dash को लेफ्ट हैंड साइड लेके जाएं तो इसको राइट हैंड साइड लेके जाना पड़ेगा. Therefore T dash is equal to R dash minus R naught upon R100 minus R naught in 200. What is the value of R dash? 5.795. What is the value of R naught? 5 ohm. R100, that is 5.23 minus 5 into 100. Now you will get T dash is equal to 345.65 degree Celsius. When you will calculate this, you will get 345.65 degree Celsius. So temperature of platinum wire is 345.65 degree Celsius when thermometer is inserted in a hot bath. So this way we can get final temperature. In example 3.3, what we have obtained? In that, what we have obtained? In that also we have obtained temperature. Here also we have obtained temperature. If value of resistance is available to us, then we can find temperature. If value of temperature is available to us, then we can find a value of resistance. So using this formula, R is equal to R naught 1 plus alpha T minus T naught, or rho is equal to rho naught 1 plus alpha T minus T naught, we can get the value of resistivity or resistance at different values of temperature. Now I am giving you some numericals in homework. Same way you have to calculate that numericals. Exercise numerical 3.5, 6, 7 and 8. Total 4 numericals I am giving you in homework: 3.5, 3.6, 3.7 and 3.8. That numericals you have to solve on your own. Simple, this formula you have to apply. Try to solve that numericals. If you have any query, then you can ask me. So with this I am ending today's lecture. मिलते हैं नेक्स्ट लेक्चर में, तब तक के लिए बाय बाय, थैंक यू.